Okay, so suppose $100 is invested at 7% nominal rate compounded quarterly. We're going to find a formula for the amount that you have in year T. So here's my time, T in years, and here's my amount, the amount in year T, and that's in dollars. And in year 0, right at 0 time has passed, right after I put the money in, I have $100. Okay. Now, every 3 months, or 4 times per year, they compound the interest. So what does that mean? So after 0.25 years, or 1/4 of a year, they've looked at the $100 that you put in. They give you back the $100, and they give you some interest. They don't give you 7% of the $100. That'd be $7. They don't do that. They give you 1/4 of the 7%. All right, so that's half of 3.5%, whatever that is. Okay. And then after half a year, it's years, they take what you had in March, they take this whole amount, whatever you get from this arithmetic, they take that, and they multiply it by 1.07 over 4. Again, so you come down to September, 0.75 years. You've multiplied 3 times, and after a full year, since you're compounding quarterly, you've multiplied by 4 times. Okay. So you come down to 2 years. And by then you've gotten interest 8 times. Keep going, however long you want to go after T number of years. We'll see in 1 year it was 4 times, and in 2 years it's 8 times, and in 3 years it's going to be 12 times. All right? It's doing 4 times per year times however many years. So 4t should be the exponent. And so, what's our formula? So I have my principal, the $100 initially invested. Okay. And then over here, the R is the rate, the 0.07. And the N is the number of times compounded per year. Okay, and then here I have, it's 4 times per year, it's 4 times t, so NT. And the t is the time in years. Okay, so you need to remember the amount is P, 1 plus R over N to the NT. And so if I said it was compounded monthly, the N would be 12. Right? So quarterly, well, let's do annually. N is 1 time per year. Or if you say quarterly, that means 4 times per year. Or if you say monthly, N equals 12 times per year. And for this purpose, the bank will sort of pretend that all the months are equally long, right? 365 days, you can't divide it by 12 exactly, but they pretend. Okay. And then daily, so forth. Okay. Now, let's see. So you can do different kinds of problems. You can say, how much principal would I have to put in order to get a certain amount after 10 years? Or you can say, how many years would it take to reach a certain amount? So, or you could ask, what would the interest rate need to be to reach a certain amount in a certain time? But once you've got the equation with the letters in there, you know, if you know all the other numbers except for one, then you can do algebra to find the one that you don't know. Okay. So let's do an example problem here. Let's see. Let's suppose you're getting 10% interest and compounded well, let's do monthly. And you need $500. Well, let's see. We're thinking ahead for some big purchase. Okay, you need $50,000, and 2 years for a down payment on your house. Okay. How much do you need to invest now? Okay. So the amount in year T, it's the principal times 1 plus R over N to the NT. We're going to need $50,000 in 2 years. So that's some amount we don't know that we have to put in right now. At a 10% interest rate, compounded 12 times a year, and you're going to leave it for 2 years, so it's 12 times 2 here. So 50,000 is P times whatever this is. So how much principal do we need to invest? It's $50,000 over whatever that is. Now, let me do that with a spreadsheet. What's whatever? So let's see, what is that? It's 1 plus 0.10 over 12 to the 24th power. So I'm just doing this piece right here. You can see that. So it was, it's my $5,000, $50,000 divided by about 1.22. So really the right way to do calculations is to avoid rounding off whenever you can. See? So the way I'm going to do this over here in Excel is I'm going to take equals, and I'm going to say my $50,000. And then I'm just going to click on this cell here. Because it's really, it's kept digits, more digits even than show in the cell there. It's kept, you know, something like 16 digits in the memory inside. So anyway, it's just a good habit to not round off intermediate steps when you're doing calculations. Okay, so anyway, the principle that I came to over here is $40,970. And let's see, Dylan was asking in the chat, for the 11.1 excursion, do you have to do the car loan problems? Yeah, you know, you can read. There's like lots of description in the book, and so I'm going to kind of leave that part to you. If you're having trouble with it, send me email. You know, I could talk more in our next class. You know, and if you're getting stuck real bad, let me know, and I could extend the date or something. But I think it's going to go okay. I don't think you're going to have trouble, but we'll see. Yeah. Okay. Yeah, so that's the practical part of compound interest, except we need to do one more topic, which is continuous compounding, and you need to know what APR is. They talk about APR financing. That's related to this continuous compounding idea. And I'm happy to report that the continuous compounding idea has deep connections to other parts of math, including what you've learned about complex numbers just recently, believe it or not. So that's the part I really want to get to. You know, I think the practical part will be more useful to you, but I want to get to the kind of cosmic part, and then that'll be the end of the semester. So that does it for this video. And I think what I'll do is I'll stop at this point, and after you've worked some of these problems, in my next video that I put out, either in a class session or I may just post it so you can watch it before the next class session. We may do it in class on Wednesday, or I may post it. But I'll do the cosmic part there. And so I'm going to stop the recording here.